This video is about what I'm going to call an increasing number. An increasing number is when the digits in the number are increasing. So I've given you some examples. 123 is increasing, but 312 is not, nor is 113. So an increasing number has to have distinct digits. None of the digits can be the same. A quick fact about these that we're going to utilize is that for any collection of digits, distinct, there's exactly one increasing number that can be created using those digits. And so if I give you the digits 2, 5, 8, 3, 1, there's only one increasing number for those 5 digits. 1, 2, 3, 5, 8, 12,358. Even though there turns out to be 120 numbers that can be created using those 5 digits, 5 factorial, there's only one of them which is increasing. So when I say how many 2-digit increasing numbers are there, there's a couple ways to do it, but the best way to do it is to say how many pairs of 2 digits can you get? That's the same question, right? As long as I can find all the pairs of 2 digits, then I can find all the increasing numbers. And so if I start and think about how to do that, there's a couple ways you can do it. One way is to start thinking. If I pick 1, how many numbers can I pair with 1? Well, it's all of them except for 0, because 0 can't be a part of an increasing number because it would have to be the first digit, but it can't be the first digit. And so it starts with 1, and so there are 8 digits after that can be paired up with the 1. So now if we get rid of the 1, we just think about the 2. We ignore the 1, and so there's only 7 other digits, 3 through 9. And so you see a pattern developing. And so the number of 2-digit pairs, or pairs of 2 digits that there are, is just going to be 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1, which turns out to be 36. So there's 36 pairs of numbers, and so the answer is 36. Another way to do that is to say, well, I've got 9 numbers for the first digit, and then 8 numbers for the digit after that. But if I count that, that includes 1, 2, and 2, 1, so I have to divide it by 2. 9 times 8 divided by 2 is 36. Those of you familiar with combination theory, this is just 9 choose 2. Example 2 is the same idea. How many 4-digit increasing numbers are there that are greater than 5,000? Well, that might seem like a pretty daunting problem, but because it's greater than 5,000, our thousands digit has to be 5, 6, 7, 8, or 9. However, if it's increasing, it can't be 7, 8, or 9, because there's no way to have an increasing number that's in the 7,000s. So instead, we have the first one, which is 6, 7, 8, 9, and that's the only way to not include a 5, so there's one of those. And then the question is, how many ways can I select digits that are from the set 5, 6, 7, 8, 9? Well, you can think about it as leaving out. We got 5. Basically, we're starting with a 5, and so we're going to leave out a digit. We're either going to leave out 6, we're going to leave out 7, we're going to leave out 8, or we're going to leave out 9. And so there's exactly 4 ways to leave out one digit. And you could go through and list them pretty easy, right? 5, 6, 8, 9, 5, 6, 7, 9, and 5, 6, 7, 8. Those are all the increasing numbers, and so the answer to this question turns out just to be 5. So you've got to think about what digits can't you use, and then you've got to use some sort of nice counting technique to get to the answer. Listing them out is fine, but if you can think of a better way to do it, that's all the better. In this case, the answer would have been, for it to be greater than 5,000, then it has to only use digits 5, 6, 7, 8, 9. You need 4 of them to make a 4-digit number, so you do what's called 5 choose 4, and 5 choose 4 just equals 5.